Overload. 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 Overload.
Imagine this, one aluminum can recycle is like saving energy to turn on our TV for 2 hours and running our computer for 3 hours. 1 ton of aluminum recycled is equivalent to 13 tons carbon dioxide prevented, save 37 barrels of oil. Paper is the most common item found in our trash. Recycling 1 ton of paper saves 17 trees and saving 4,100 kilowatt hour of electricity. Recycling 1 ton of plastic saves 1 to 2,000 gallons of gas. Segregation is easy and recycling can be fun. Here's how. There are 3 categories of waste: biodegradable waste, recyclable or residual waste, and special waste. Biodegradable waste. These wastes can decompose by themselves with the aid of natural factors like oxygen, sunlight, and enzymes. Examples are vegetable and fruit peelings, garden waste like grass, weed and ash, and spoiled food.
Special waste. These wastes pose health hazards. On these categories are tins, thinner, sanitary napkins, diapers, clothes, and hospital waste like used medical supply. Recyclable or residual waste. This category composed of waste that can be reused or recycled, like paper, newspaper, magazines, bottles, whether glass or metals, plastics like container, straw, rubbers, cans of milk and soft drinks. In your homes, for sure, some falls under these categories. So, for the starts, all you have to do is to determine whether your waste is biodegradable waste, recyclable or residual waste, and special waste. Then segregate! Have separate containers for them so they won't scatter and spoil your place. Use biodegradable waste to make compost, which can be used as fertilizer. For the special waste, put them together in plastic container. Private truck will collecting them for proper disposal. According to research, 60% to 80% of man's garbage can be reused or recycled. Gather all the recyclable and residual waste and bring and sell it to the nearest recycling center or facilities. Just put together of them and make money off them. You also can make use of this material in paper if you need to. Waste segregation and recycling. You lose nothing, you benefit from it.
Leachate from the landfill flows by gravity to the leachate pond. Washing wastewaters from both the sorting area and the truck washing bay are settled in sumps and screened before flowing in pipes under gravity to the leachate pond. These wastewaters form only a small fraction of the volumetric flow rate but contain fresh leachate with high BOD and detergents and other chemicals used in the washings. The sumps will gather substantial amounts of sediments and need to be regularly desilted using a mobile sludge pump. Sludge shall be disposed into the landfill. Leachate from the leachate pond is pumped into the anaerobic stage of the leachate treatment plant. This may be a simple pond partially filled with adsorptive media to hold biofilm biomass to be at high concentrations. Generally, more than 10 gram per liter is achieved in biofilm system as compared to only about 3 to 4 gram per liter in suspended biomass systems, provided media which support thick biomass layers are employed so as to shorten hydraulic detention time (HRT). Gas is gently blown into a gas cleaning stage. This may be a wetted gas biofilter to substantially remove the water-soluble hydrogen sulfide and ammonia. A wetted gas biofilter holds bacteria on adsorptive media, and the wetted surfaces freely remove the soluble acidic gases from the biogas, so as to protect the biogas engine from corrosion. Biofilm developed on the media nitrifies ammonia to nitrate, and this is denitrified in the lower biofilm layers. The ammonia hydroxide also reacts with the sulfates and carbonates form, thus neutralizing the acids while being itself neutralized. Scrubbed biogas is stored for use to generate electricity using a small biogas engine. The electricity may be used to run the pumps and blowers, with power from the grid giving the booster power.
Desludging is carried out at least once a week, and sludge is devoted using an elevated sludge drying bed. Leachate from this drying bed returns by gravity to the inlets of the anaerobic stage. High biomass anaerobic stage, such as those with media, should remove about 70% of the organics. The effluent will then flow by gravity to the aerobic stage. The aerobic stage also contains absorptive media to ensure high biomass concentration and denitrification. Denitrification converts nitrate from ammonia into harmless nitrogen that then escape to the air. Denitrification will occur if media which supports the biomass layer is employed. The aerobic stage should be designed to prevent short-circuiting in order to achieve load BOD and COD. After clarification, the effluent should polish preferably in a non-chemical process such as a multimedia bed so as to meet the discharge standard. The treated effluent should be discharged to the on-site retention pond for runoff, where its water may be reused for washings and dust and fire control. From the aerobic stage, sludge is pumped out to a sludge thickener and further sludge processed. Then the treated leachate effluent will discharge to treated leachate ponds before it goes to river.